Okay, so now we know what the value of a gas-fired plant is once that's in place. So the next step, or basically an intermediate step that we'll do, is to look at the option problem of if we just have the option to invest in this gas-fired plant, so have a piece of land, a plot of land, a green field if you wish, and we have the option to make the investment to get this gas-fired plant, of which we now know the value once it has been built. So it's going to cost us some investment cost I, and the question of course again is, for what price of gas, or what price of the fuel, will we want to make this investment, and on the other hand, for what prices of gas would we rather wait with making this investment? So that's what we'll investigate now. So we have figured out this VG, right? That was the value of a gas-fired power plant, and it depends on P. So if P is high, it was this value of this plant would be suspended, the operations would be suspended, so it would not be producing, but it still had some value because we could switch it on as soon as price drops below the electricity price. Whereas if price for gas is already below the electricity price, then we actually had some additional value from being able to produce, plus the option value of being able to shut down if P inadvertently might rise again. So we know what the value of that finished plant is. So the question now is, do you want to invest in this plant, right? Now, of course, that's going to depend on what the gas price now is, because that's going to matter for the value of this plant. So the question is, when should we invest? So for what values of the price P, of the gas price P, should we be making this investment? So for the moment, let's just ignore that there might be this alternative option of investing in the biomass plant. So what we have to do is, we have to again compute what's the value of the option to postpone investment, just like we did before. So let's do that. So again, of course, we have to identify the different regimes. So now this regime in which we'll be waiting will be the regime in which gas price is going to be pretty high, so above some threshold that we need to compute. Because if gas prices are high, well, it's certainly going to be very unattractive to invest in a plant that burns gas to produce electricity. So that's the waiting regime. So in this waiting regime, of course, there is this option to invest. And the option derives its value from the fact that P might drop below this threshold price at some time in the future. And this option value, of course, satisfies this waiting Bellman equation without any cash flows, because we're not getting anything. We just have this green plot of land. So this is our standard Bellman equation, and we know what our standard solution is here. So generally it's going to be, take the form again, as always, of this combination of these two power functions with D1 and D2 to be determined, and of course P star is going to be determined later. So let's look at the boundary conditions here. So for this regime, it extends all the way above P star, right? For any P above this threshold value that we still need to determine. So including if P goes very large, and we have to make sure that if P is really large, so the cost of gas is really large, then of course the option to invest is going to be sort of virtually valueless. So that means if P gets very high, of course this thing goes down to 0 because beta 2 is negative. So a big number to a negative power is going to be 0. But a big number to a positive power is going to blow up. So we don't want that thing. So this option should approximate a value of 0 whenever P goes very big. So that means that D1 must be 0 here. So we can actually get rid of this D1 term. So the only term here that's left is this D2 term. So the value of this option value is going to be just this term, essentially. And we still have to figure out how big D2 actually is. And then, of course, on the other side of this domain of this regime, we'll have the threshold price which will make the investment, and there will have value matching and smooth spacing to the other regime, and the other regime will be the regime in which we do make the investment. So that's the investment regime, if you wish. So if the gas price is small, so below this threshold that we need to find, P star, then we'll invest I immediately, and we get this gas-fired plant. we know what this plant's value is. It was this VG of P that we just computed in the previous part. So we know that if price is below P star, what we get is the value of a finished plant, of course, minus the investment cost that we incur from building this plant. So we know what VG is. So it had these two parts. You remember it has this: if P was bigger than A, bigger than the electricity price, it was the value that we get if the plant is idle, so when operations are suspended. Whereas if the gas price is below the electricity price, we had this total value that we had in the production stage. So just to look back at those expressions, these were these. So when operating, VG looks like this. So it's the operating profits plus its option value of suspending operations if P arises again. Whereas if price is above the electricity price, we just had this option value of being able to switch on the plant again when price gets below A. So this is the value V of G. So it's defined in these two different regimes. So we have that, these two option values. And we're of course going to make the assumption that once we make the investment decision, so we're still in this green field here, we're going to make this, to build this plant, and we assume we'll certainly wait for a gas price which is below A itself, below the electricity price, because otherwise you would build a plant which first sits idle and there's no use in that. So this P star will certainly be below the price for electricity A, because otherwise you better wait a bit. Okay, so we know what VG of P is, and it's this production part of the value of the gas-fired plant. Okay, so let's summarize what we have. So on the one hand, there will be some threshold. On one side of this threshold, we will be in the waiting regime. We'll wait with building this plant, and there, indeed, we only have this negative power, basically to depict the value of waiting until P drops sufficiently far for us to make this investment. And below this investment threshold, we'll immediately make the investment, and we get this VG of P that we computed. We will be already in this production phase, so that's the expression that we have, is this particular VG of P as a function that we know, minus, of course, the investment value. And now, of course, we have to add to that the boundary conditions at P star. So there again we have value matching and smooth pasting. So these values have to match up at P star. That's the first equation. The waiting value should equal the NPV basically of making the investment at that point. And secondly, this waiting, the derivative of that waiting option value over here should equal the derivative of that plant, so that they are nicely fitting together. And these equations you can also find in the paper by Morton Nason. So it's not too difficult to eliminate from these two equations D2. So we do this in the same way as we did before. So that gives us an equation for P star. So this equation for P star is a little bit of a more ugly equation than we had before. So we cannot usually solve this completely explicitly. But what we can do is actually solve this numerically. And actually that's what Morton Nason do. And they plot a graph of what this value of P star will be for given parameter values, in particular also for the given volatility of that price process. So you can actually solve for P star then, for this single equation in P star that you get, you can solve that numerically. Okay, so that completes basically our analysis in the sort of simpler case in which we only have to make the decision to invest or not to invest in this gas-fired plant. So the next thing that's on our program is, well, let's now make this slightly more complicated, because we are going to add that instead of waiting with investing in the gas-fired plant, we might also make this alternative investment, namely investment in the biomass plant, and giving up altogether the option to invest in the gas-fired plant. So that will be the topic of the next part.